Welcome to this explainer. For the last few years, we've basically been living in an era of AI that talks. We've got models that can write poetry, summarize dense documents, and describe complex images with just unbelievable accuracy. But there is a massive shift happening right now. We are actively moving from AI that simply talks to AI that actually acts in the real world. Today, we're unpacking a groundbreaking new foundation model developed by Microsoft Research. It's called Magma, and it is an AI designed not just to see and describe, but to truly understand, plan, and execute. Picture this. Current vision language models, or VLMs, are amazing at describing what they see. If you give a VLM a picture of your kitchen, it has the verbal intelligence to tell you exactly where the fridge is, what color your cabinets are, and probably even guess what's currently cooking on the stove. But if you ask that exact same model to make a meal, or literally just open the fridge door, it completely freezes up. Why? Because current models lack spatial-temporal intelligence. They have the vocabulary, sure, but they completely lack the ability to ground those words in physical space or plan a sequence of actions over time. Here is our roadmap for today. We'll start with 1, AI's missing link. Then look at 2, enter the Magma model. Next up, 3, grounding and planning actions, followed by 4, architecture and massive pre-training, and we will wrap things up with 5, state-of-the-art results. Section 1. AI's missing link, the domain gap.
So what does a true multimodal agent actually need to do? It has to take a human goals, something like close the middle drawer, use its understanding to perceive the environment, and then translate all of that into precise action prediction. Historically, though, AI models have been trained in completely separate silos. You had models trained strictly for 2D digital web tasks like clicking around a user interface, and then entirely separate models trained for 3D physical tasks like moving a robotic arm. Trying to combine these two, it created a massive domain gap. The language of a flat 2D screen is just fundamentally different from the complex 7 degrees of freedom required to operate a physical robot.
Section 2. Enter the Magma model, the universal bridge. This is where Magma steps in, and it's honestly a real game changer. Magma acts as a true generalist foundation model. Instead of being trapped in just one specific domain, it seamlessly handles an entire spectrum of tasks. In one moment, it can navigate a digital environment, figuring out exactly how to install the Instagram app by understanding a phone's user interface, and in the very next, it can operate a physical robotic arm to pick up a mushroom and gently place it into a pot. It keeps all the rich verbal intelligence of previous models, but it finally adds the ability to manipulate both the digital and physical worlds. Section 3. Grounding and planning actions. How Magma thinks.
So how do you actually teach an AI to interact with its environment like this? Researchers at Microsoft came up with a brilliant solution called Set of Mark, or SOM. Think of this like the ultimate virtual sticky note system. When Magma looks at an image, say a screenshot of a smartphone app, it essentially places numbered virtual sticky notes on absolutely everything it can interact with. Every clickable button, every search bar, every tiny icon gets a number. By predicting which numbered mark to interact with based on whatever the user's goal is, Magma transforms a basic, static image into a rich grid of actionable data. It completely grounds its intended action in the visual space.
But static images are really only half the battle, right? To accomplish physical tasks in the real world, you have to be able to plan over time. That is where trace of mark, or TOM, comes in. If set of mark is our sticky note, trace of mark is the map. Magma watches video data, tracks those sticky notes, and essentially draws a path to predict exactly where those objects are going to move in the future. Instead of just trying to predict the very next frame of a video like older models did, trace of mark forces the AI to look ahead. It has to plan out a long-term trajectory. It's fascinating to see how the model manages these two completely different spaces. When dealing with digital UI navigation, you see these incredibly sharp, precise red bounding boxes marking actionable areas on a screen. But for physical robot manipulation and human actions, it uses trace of marks. You get these colorful, sweeping lines mapping out the complex future movements of hands and robotic arms. Magma learns from both of these simultaneously. It masters both the precise, instantaneous clicks of a digital interface and the fluid, continuous motions of the physical world.
Section 4. Architecture and massive pre-training. The brain of Magma.
39 million. Just let that number sink in for a second. That is the sheer scale of Magma's heterogeneous pre-training dataset. The researchers didn't just use standard, boring robot data. They utilized 39 million highly diverse samples, and a massive chunk of this actually came from raw, unlabeled human instructional videos out in the wild. Think of all those first-person YouTube videos of people cooking, cleaning, or fixing things around the house. By applying trace of mark to track the motion in those videos, the researchers turned regular, everyday footage into an absolute goldmine of spatial-temporal training data for the AI.
Now, to process those 39 million samples, you need a serious powerhouse of an architecture. Magma uses a convex XXL vision backbone. This is absolutely crucial because it allows for highly flexible, high-resolution processing. That means the model can read tiny, fine-print text on a digital UI just as easily as it can spot a small object sitting on a cluttered kitchen counter. All that rich visual data is then fed directly into the Llama 3 8B language model, which acts as the core reasoning engine. Through joint training, Magma perfectly aligns text, images, and action modalities. It truly acts as the ultimate bridge between verbal intelligence and spatial execution.
Section 5, State-of-the-Art Results, Proving Magma's Efficacy. Okay, let's talk numbers and look at the zero-shot performance, meaning the models were tested without any specialized fine-tuning for these tasks. Magma absolutely dominates. On the digital side, in the visual web bench test, Magma scores an 84.1, completely blowing past GPT-4V's 71.6. But then look at the physical side in the simpler M Google Robot Simulator. A specialized, purpose-built robotics model like OpenVLA scores a 31.7. Magma scores a massive 52.3. It is literally beating domain-specific models in both the digital and physical realms without even needing to be specifically tailored to them. And when you take this out of the simulator and test it on a real, physical WidowX robotic arm, the results are even more staggering. OpenVLA manages a 25% average success rate on real-world manipulation tasks. Magma achieves an incredible 67.5%. That's nearly tripling the success rate. It perfectly illustrates just what a massive leap Magma represents for physical robotic manipulation. Breaking down some of these specific, real-world tasks, Magma excels at high-precision actions, like picking up a little toy hot dog sausage or putting a mushroom exactly into a pot. Because of its strong action grounding, it knows exactly where these objects are in 3D space. But for me, the most exciting data point here is a task called push cloth left to right. This was an entirely unseen task. The model had literally never been trained to do this, yet it pulled off a 7 out of 10 success rate. This proves beyond a shadow of a doubt that its spatial-temporal intelligence isn't just basic memorization, it is genuine generalization. It actually understands how objects move and interact in the real world. Which brings us to a pretty profound question to wrap up this explainer. We have spent years getting entirely used to chatbots that can summarize our emails or generate funny pictures. But Magma proves that the era of embodied agentic AI is officially here. When a single foundation model can flawlessly book a flight on your phone and then turn right around and physically cook you breakfast, well, everything changes. So what happens to our digital and physical worlds when AI no longer just describes them, but seamlessly acts within them? It's a wildly fascinating future, and with models like Magma, it's arriving much faster than we ever thought.